So this is the second question of Lead Code Weekly 374 contest. Minimum number of coins to be added. In this question, we'll be given a zero index array coins and a target value. And what we need to find out is the number of coins that we need to add to this existing coins array such that all the values from 1 to target are achievable. Now, if you see this test case, we have 1, 4, 10 and target value is 90. So from this array, we can find out 1, 4, we can also find out 5, 11 and such values, but we cannot find values like 2 or 3. So basically what we want to ensure is we want to find, add some coins such that all the values from 1 to 19 are achievable. Now in this question, if the output will be 2, so basically if you add 2 and 8, all the new array will be 1, 2, 4, 8, 10, and from this we can achieve all the values from 1 to 19. So yeah, let's see how we can solve this. But before that, the constraints of the target are from 1 to 10 power 5. Length of the coins array is from 1 to 10 power 5. And the coins I value is less than or equal to target. In this question, we'll be given one vector of coins as the input, one target value, and we need to return integers, which is the solution to the question. All right. So yeah, let's see how we can solve this question.
Okay, so as the question states that we need to add minimum number of coins in the initial coins array to make the target so that every value from 1 to whatever the target given is obtainable. Now what is obtainable? As the question describes, that we can add up the different points to make that value. For example, 5 is currently obtainable from this array. We can add 1 and 4 and we will be obtaining 5. Now before moving further in the solution, one observation to make here is that if we want to achieve a coin with value x, then any coin which has its value less than equal to x can contribute in making that x, but any coin with a value greater than x can't contribute. What I mean to say is, suppose we intend to make a coin with value 5, then any point from 1 to 5 can be taken, different combinations of them can be taken to achieve 5. But any number which is greater than 5, like 6 to whatever range we want to take, we can't use them to obtain 5. Now moving further, so we have to add, the question asks us to add minimum number of coins in the initially given coins array to make up the target. Target here is 90. So what are all possible values is the question asking us to make? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up to 19. We need to make up these values with the coins available, and if we are unable to make any of these values, we need to add a coin. So now let's see how can we add a coin. So initially, these are the target values that we need to achieve. Is 1 achievable from the currently given coins array? Yes, it is. We can simply choose a coin with value 1. Moving further, is the value 2 achievable? So clearly, as I stated, any number which is greater than 2 is not responsible to make up a value of 2. So 4 and 10 in this case are useless. They can't contribute to make a value 2. Then we are left with only one coin, which is 1. Now 1 is not equal to 2. So we need to add a coin here. So we have two options. First is we add another coin of value 1, which is make up to the value of 2. Although it's a right way, but it's not an optimal way. Because if we add a coin with a coin of value 1, we are restricting our range to 2 only. As we will move further, we will encounter 3 here, and again we will be left with no choice to add up a coin. But since we have to add minimum number of coins, we should be looking for the maximum range that we can achieve by adding a single coin. So here in this case, when we have to make 2, instead of adding 1, we will add a coin of value 2. Since we are free to choose any coin of any value, we will be going with 2. As 2 is equal to 2, we are done with 2. And 2 plus 1 will increase the range up to 3. So we are also done with 3. Similarly, moving further, 4 can be achieved. 5 can be achieved as the array is now 1, 2, 4, and 10. 5 can be achieved, 6 can be achieved, and 7 can be achieved. But as we move to 8, the maximum sum that we can obtain from these 3 coins is 7. And another coin that we have present in our array is 10. Since 10 is greater than 8, so as also discussed above, it can't contribute in making 8. And we have the maximum sum as 7. So definitely we need to add a coin of value 8 here. So what observation we gain from here is that what is 7? 7 is the prefix sum of this array that we have been maintaining. So any value which is less than or equal to prefix sum is achievable with these points, and any value which is greater than prefix sum and also the other points present in the array can't contribute, we will have to add up a coin here. So since we are maintaining prefix sum and we need to give the minimum number of coins, starting we will be sorting the array, the coins array that will be given. So moving further, now our prefix sum value after adding 8 will become to 15. So every possible number up to 15 from 1 to 15 is achievable using these coins 1, 2, 4, 8, and 10 is already present in our array. So moving further, we encounter 9. Is 9 achievable? Yes, it is. 10 plus 1. Then we encounter 10. Although 10 is achievable from these numbers 8 and 2 or 10 itself, any of the case, but since it was already present in the array, and while traversing our target array, which was 1, 2, 3, 10, while traversing our array, we also encountered this. So we, in such cases, when we encounter any value and it's already present in the array, we can increase the range of our prefix sum by adding up that value. The range of our prefix sum previously was 15. Now we can add it up to make 25. So clearly it can be proven that any value up to 25 is achievable with these coins only 1, 2, 4, 8, and 10. And since 19 lies in this range, 19 is less than 25, we can achieve 19 with these coins. So the number of coins that we added here is 2 and 8, which is 2. So we need to return 2 from the example. The key take from here is that we can achieve a maximum value greater than or equal to the prefix sum. Prefix sum.
So this happens because until we reach that point, everything before that is already calculated. So we know we can find that out.
Yes.
So just for adding one more, we just check the prefix sum value.
Prefix sum value. And since we have to return the minimum number of points, we, instead of adding 1 to it, because 1 or whatever the value is required to make up that number, we add that number itself.
Okay.
For example, the prefix sum here was 7 and we needed to add, make it 8. So instead of adding 1, we added 8 itself.
Okay.
Because if we would have added 1, the range will be up to 8. But since we added 8, it increases our range to 15.
Right.
So we want to maximize our range so that we can minimize the number of points.
Right. What's the time complexity of this?
Time complexity, since we need to initially sort the array, it will take a time complexity of O n log n, and we are traversing from 1 to whatever the target value we are given. And in the worst case, target value as mentioned in the question is 10 to the power 5. So we can say it is O to power O of n. And since we are not utilizing any extra space here, so the space complexity comes out to be constant, that is O of 1.